Hi everyone, welcome once more to Best Science Brain YouTube channel. Today we are presenting solution to NECO July 2024 practical chemistry. If you are not subscribed to the channel, kindly move up to the channel's name Best Science Brain. Below the video as it's playing, you see the Best Science Brain, the channel's name. Under it, you're going to see the subscription button that looks like a tiny bell. Tap on the button or the bell only once. Tap on it only once and get subscribed to the channel for more videos. So this is Chemistry NECO 2024. We're presenting 100% solution to all the questions here given in this examination. And then for the titration part 1, we are working with our endpoint. The experiment we did on this channel with the NECO specimen, you can search our channel. We got our endpoint as 20.30. And for you as a student that writing examination watching this video, please use the endpoint given by your school teacher. If the endpoint that we used in this calculation tallies or agrees with that one given by your school teacher, then our calculation will be perfect for you. But if your teacher gave you a different endpoint, then use this endpoint. What do I mean by endpoint? Endpoint is VA. The average titer you get for your table, VA, that represents your endpoint. So whatever we use our VA, you use your own and substitute in place of our own. We're using 20.3 in this calculation. So if you're using 20, if you're using 21 point or whatever, our own will agree with your own if your endpoint is 20.30 plus or minus 0.1. Perhaps you have 20.20, 20.30, or 20.40. Then you can use that table. But if your endpoint is out of this range, use your teacher's endpoint to manipulate your table and then do the calculation. The calculation is the same step, but you now use VA in place, your own VA in place of our own VA. So let's go to question part 1. Practical. Answer all questions. 1. All bullet readings, initial and final, as well as the size of the pipette, must be recorded, but no experimental procedure is required. All calculations must be done on this question paper. Question says, A is a solution containing 4.40 grams of tetraoxo sulfate acid per dn cube of solution. B is a solution containing 7.50 gram of impure sodium triazocarbonate 4 per dn cube of solution. Okay. Titrate A against 20 or 25 cn cube of B using methyl orange as an indicator. Repeat the titration 3 more times and record your results in table 1.1. So we'll go to the table right now. So you can see the table 1.1. The first there is the volume of pipette used. You're given a gap to fill, and of course we have 25.00 cn cube. Fill to 2 decimal places. So the pipette used, the common one is 25.00 cn cube. Then table 1.1, we have titration, final readings or final burette readings, initial readings or initial burette readings, the volume of A used in cn cube. Then under the rough column, we have 20.70 as final, 0.00 as initial. You subtract, we have 20.70 as volume of A used, that's the titer value. Then for 1, we have final 41.00, initial 20.70. Subtract, we have 20.30 as our volume of A used. Then number 3, number 2, we have final 25.30, initial 5.00. Subtract, we have 20.30. Number 3, final, we have 30.30, initial 10.00. We subtract, we have 20.30. We repeat, we have the rough, the final 20.70, initial 0.00, subtract, we have 20.70. Number 1, final 41.00, initial 20.70. 41 minus 20.70 gives us 20.30. Number 2, we have 25.30 as final, initial 5.00, subtract, to 5.3 minus 5 gives us 20.30. Number 3, final 30.30, initial 10.00, subtract to have 20.30. So there are a lot of things you have to avoid on this table. So you don't have to put your readings to one, that is readings like 20.7, 41.0, 25.3, 30.3 are wrong. All the readings here must be to two decimal places. 0.0 is wrong, or ordinary 20 is wrong, or ordinary 41 is also wrong. So all the readings there must be recorded to two decimal places, please. And then you have to avoid arithmetic error. When you subtract the values, you see that the values are accurate, no error. So you know what you are doing. So we'll now go to question A. It says, calculate the average volume of AUs. That's our VA, which you normally call your endpoint. Our VA now becomes 1 plus 2 plus 3. Taking 1, taking 2, and 3. We took 1, 2, and 3 because they are consistent. Readings are concordant. They are in agreement. So we have 20.30 plus 20.30 plus 20.30 all over 3 in CN cube. And that gives us 20.30 CN cube. Everything from the table to your VA, everything must be recorded to decimal places. So that is our working endpoint, 20.30 CN cube. We'll now go to BI. It says concentration of A in mole per DNQ. We're looking for now CA. That is the symbol. So we'll have to first of all start by find the molar mass of that C, which is H2SO4. Picking the atomic mass of hydrogen, sulfur, and oxygen from the equation. Hydrogen is 1 multiplied by 2 because of 2 atoms. Sulfur is 32, and oxygen is 16 multiplied by 4 because of 4 atoms. That gives us 98.0. Your calculations, after the table, all the calculations you'll be doing, you have the values should be given to 3 significant figures, SF. So we didn't write 98, we write 98.0 gram per mole. Look at the mole. There's -1 up, gram per mole. So we now have the concentration of A in gram per dn cube, which is given in the equation, which we write as PA or rho A symbol. Concentration of A in gram per dn cube in the equation given to you as 4.40 gram in 1 dn cube. That is 4.40 gram per dn cube. And then we'll now go to calculation to get our CA, that the concentration in mole per dn cube, that is CA, is given by concentration in gram per dn cube all over molar mass, which is 4.40 over 98. When you divide this, you'll be getting CA as 0.0449 mole per dn cube. 0.0449 mole per dn cube to 3 significant figures. If you don't put your value to 3SF, then get ready to fail. To 3SF, whenever equals to come, it is going to be preceded by value in 3SF. Look at 98.0. And look at this one, 0.0449. I did not say 3 decimal places, 3SF. So you have CA. So this CA answer is the same for everybody. CA is not calculated from the table. It's not obtained from the titration table. It's obtained from the information given to you in the question paper. So the value of CA should be uniform for every candidate writing this examination. No difference. We'll now go to question II. We are asked to find the concentration of B in mole per dnq. That is our CB. So we are getting our CA from question I as 0.0449 mole per dnq. Our VB, the pipette we're using is 25.00 cn cube. If you're using 20, then your VB should be 20, but 25 is most common. Our V is the endpoint. So from the table, our V is 20.30. If you're using a different value in your own school, then your VA should be what you're using in your school. Let's assume you're using 19.10, then your VA should be 19.10. Let's assume you're using 25.00 from your school teacher, then your VA should be 25.00. So for here, substitute VA with whatever value you're using in your school. Then every other thing remain the same except for VA, which could vary based on what you're using in your school. So yeah, NA, ratio of NA to NB, for the mole ratio in the balance equation is 1:1. So since we know everything except CB, we apply the titration formula CAVA over CBVB equal to NA over MB. We make CB the subject. CB becomes CAVA times MB all over VB times NA. Substitute appropriately with the values. Your CA is 0.0449. Your VA, that's the endpoint from your school. For here, we're using 20.30. Our MB, that the mole ratio of the base, is 1. Then our VB, that is the volume of the pipette, which is standard, 25. And then our NA is 1. Solve out. We're going to have our CB as 0.0365 mole per dn cube to 3 significant figures. 0.0365 mole per dn cube to 3 SF. So our question 3 is III, that's A. Triple I says, consider B in gram per dn cube, that's reacted. So we are looking for the mass consider the base, that is PB or rho B. The molar mass of the sodium carbonate is calculated using the atomic of sodium 23, carbon 12, and oxygen 16. Multiply 23 by 2 because of 2 atoms of sodium there, and then add to carbon, which is only 1 atom, 12, and oxygen 16 multiplied by 3 because of 3 atoms there. We're going to have 106 gram per mole at the molar mass of sodium carbonate. And then our CB, which was obtained in the previous question, is 0.0365 mole per dn cube. Your CB may differ if you're using a different endpoint from our own. The value of your CB will differ, but the procedure remains the same. Just replace your VA, whatever value you got in your school, the value of your CB will be different, then follow the same process. So the concept of in gram per dn cube, that is PB, becomes CB times molar mass. So the value of your CB you got here is 0.0365. The molar mass of the carbon is constant, 106. The multiply, you have 3.87 gram per dn cube to 3 SF. 3.87 to 3 SF. Question number IV says mass of impurity in 1 dn cube of B. Because we are told that B is an impure substance. So the mass in 1 dn cube is what's called the mass concentration. So we can now say the mass conc of impurity, which you can call P asterisk, equal to mass conc of impure sodium carbonate, given to you in the equation, minus mass conc of pure carbonate, PB, which you obtained in the previous question. So the mass conc of impure carbonate in the equation is 7.50 minus mass conc of carbonates, pure carbonate is PB, that reacted, which you got in the equation before this one as 3.87. So now I have 7.50 minus 3.87, that gives us 3.63 gram per dn cube, also written to 3 SF. Then number V says we should calculate the volume of carbon dioxide released or liberated by 1.0 dn cube of B. We have the balance equation there, sodium carbonate and H2O4 and sodium carbonate, giving us sodium sulfate, water, and CO2. The equation given is given the equation paper. So we're working with the solution B, which is sodium carbonate. So for the balance equation, we have 1 mole of the carbonate liberated 1 mole carbon dioxide. That is the statement we make first. Then we'll now go ahead and say 1 mole of the carbonate liberated 22.4 dn cube of CO2. And you know that since we're talking about 1 dn cube, the number of moles in 1 dn cube of the carbonate is nothing but your CB. We'll now say 0.0365 mole, depending on what you got as your CB. So from here, our CB is 0.0365. So if you got a different value, then replace 0.0365 with your own CB. Okay, so 0.0365 mole of the carbonate will give us 0.0365 times 2.4, and that will give us 0.8176 dn cube of the gas. And since our answer should be kept to 3 SF, that becomes 0.0818 dn cube of carbon dioxide. Then, or you can leave it in centimeter cube, multiply 0.818 by 1,000, since 1 dn cube is equal to 1,000 cn cube. That gives us 8.18 Cn cube of carbon dioxide at STP, 8.18 Cn cube of CO2 at STP. We'll now go to question number 2, which is qualitative analysis. It says candidates are advised to adhere strictly to the instructions given. All observations and inferences must be clearly recorded in table 1.2. Identify any gas or gases given off. So let's go straight to the question. So in the question, the tests were written for the students. Then you do the test according to the instruction it's written for you. Then all you have to do is fill the observation and the inference. So let's go to question 1 that says C plus 5 Cn of distilled water and shake thoroughly. Divide the solution into 2 portions. Observation should be C dissolved completely in water to give a colorless solution. Test tube felt warm to touch. So when we do the live practical, that's what we observe. C dissolved completely in water to give a colorless solution. Test tube felt warm to touch. Inference, C is a soluble salt. Full stop, the solution is exothermic. This solution, I did not say reaction because it's a physical process. This solution is exothermic. Go to question number, the AII that says, to the first portion, add sodium hydroxide solution in drops. Observation, we're going to have white gelatinous precipitate. Avoid using abbreviation. White gelatinous precipitate. Then inference, zinc 2 ion, aluminum 3 ion present. Don't ever use and. Use comma between the 2 ions because it is one salt, and being only one salt, you cannot use and. And one salt should contain only one cation. So you cannot use and. If you use and, that means you're telling us that there are 2 cations inside one salt. C is just a salt. So there should be 1 cation there and 1 anion. So that comma means zinc 2 or aluminum 3 is logical. Okay. Then III says plus then in excess. There is something added in excess now. We're going to observe white gelatinous precipitate dissolved to give a colorless solution. White gelatinous precipitate dissolved to give a colorless solution. Then also the same inference, zinc 2 ion or aluminum 3 ion present. That is zinc 2 ion, aluminum 3 ion present. The same comma, never you use and. Then going to IV that says, the second portion, add sodium hydroxide solution in drops. Second portion, add ammonia solution in drops. That is, I repeat, IV. Second portion, add ammonia solution in drops. Observation should be white gelatinous precipitate. Then the inference also, zinc 2 ion, aluminum 3 ion present. Zinc 2, aluminum 3 ion. V says then plus then in excess, that you're adding ammonia in excess. So observation should going to be white gelatinous precipitate dissolved to give a colorless solution. Inference, this time you now write only zinc 2 ion confirmed. So these ions we have been mentioning here must carry their charges. You don't just write only zinc or write only aluminum. Zinc goes with +2, aluminum goes with +3. Their charges and the sign or plus sign must also appear. So for you to score. We'll now go to question BI. Says to about 2 CNQ of solution D from add 2 to 3 drops of soda lime solution and then heat. Observation, you have a white precipitate formed, which later turned brownish on heating. So this is what we call Miller test. White precipitate formed, which later turned brownish on heating. Then inference, white precipitate is insoluble calcium salt. So you can also say calcium 2 ion present. Okay. Then under the test column, we also have test with litmus paper. You test the mixture with litmus paper. The inference should be mixture turned red this paper to blue and had no effect on blue this paper. Either mixture turned red this paper to blue and had no effect on blue this paper. So you now say mixture or solution is alkaline or basic. Then we also have a command on the test column that say and a drop of, you also add a drop of 2 molar solution of HCl to the above mixture of D and soda lime. You add HCl. So when you add this, you're going to observe brisk effervescence, or you can say rapid, but that brisk or rapid should be there. You don't just say effervescence. Liberating a colorless, odorless gas, which turned moist blue, little faint red, and lime water milky. Then he say gas is CO2, then CO32 minus confirmed. Gas is CO2 and then carbonic ion confirmed. Then BII says to another portion of solution D, add 3 drops of sodium hydroxide solution followed by 2 drops of copper sulfate solution. Then your observation is going to be a violet, in bracket, you can say purple color is formed. Then inference, proteins, in bracket, peptides confirmed, because there are 2 kinds of proteins. So the protein in milk that should contain peptide bonds. So, and it's only the protein that contain peptide bond that can respond to Burette test. This is what's called Burette test. While protein that do not contain peptides cannot respond to this test. So that's why the peptide is in bracket. So you can see that very well. So the explanation here is simple, that when solution D is heated with soda lime, the casein, that is a milk protein, will react with soda lime to form a white precipitate, which is the calcium ion. Okay? And so also we don't have time for that anyway. So that's the correct observation and inferences. Move to question 3. Question 3 says 3AI. During titration, why is the AI says funnel removed from the burette before taking the initial reading? Solution: reason, to avoid or prevent additional drops of the acid from the funnel from entering the burette. To avoid or prevent additional drops of the acid from the funnel from entering the burette. So that's why the funnel is removed before taking the initial reading. Then II says, why the burette first rinse with distilled water before filling it with acid. Why the burette first rinse with water before filling with acid. Solution: to remove impurities and neutralize. Remember that this water has pH of 7, and neutralize its content that comes to the burette. It also enables standardization to maintain accuracy and precision. I repeat, to remove impurities and neutralize its content that comes to the burette. It enables also standardization to maintain accuracy and precision. Number III. Why is it that the tip of the pipette is deep well below the surface of the alkali before sucking it? Sucking up. Tip of the pipette deep well below the surface of the alkali before sucking up. Or solution: reason, to avoid drawing up air bubbles. To avoid drawing up air bubbles, improving accuracy or improve accuracy and preventing contamination. So you see that. Number 3, AII says outline the procedure that can be used to obtain pure samples of sodium chloride from contaminated rock salt. Outline the procedure that can be used to obtain pure samples of sodium chloride from contaminated rock salt. So the procedure must involve crystallization. So we'll now move to the procedure, step by step. The first step, the salt, that means the contaminated salt, is dissolved in sufficient amount of distilled water. The contaminated salt is dissolved in sufficient amount of distilled water. Step 2, the mixture is filtered. The mixture is filtered to remove any insoluble impurities. Step 3, the filtrate is heated to evaporate a large volume of the solution or solvent and concentrate it. Step 4, heating is then stopped and the mixture is cooled to effect crystallization. Full stop. Solution is allowed to cool slowly. Step 5, the crystals of sodium chloride are filtered off using filter paper and funnel. Step 6, wash the crystals with some small amount of cold water to remove any residual impurities. Step 7, spread the filtered sodium chloride crystals on a clean, dry surface to air dry it. Then step 8, repeat the above process, which is commonly called recrystallization, to increase or improve purity. So we can repeat the process again, and this time around faster. Step 1, the contaminated salt is dissolved in sufficient amount of distilled water. Step 2, the mixture is filtered to remove any insoluble impurities. Step 3, the filter is heated to evaporate a large volume of the solvent, please, not solution, solvent, and concentrate it. Step 4, heating is then stopped and the mixture is cooled to effect crystallization. Full stop. Solution is allowed to cool slowly. The next step, the crystals of sodium chloride are filtered off using filter paper and funnel. The next, wash the crystals with small amount of cold water to remove any residual impurities. The next, spray the filtered sodium chloride crystals on a clean, dry surface to air dry it. Then finally, repeat the above process, that is recrystallization, to increase purity, please, to increase purity. So go to the next question. So the next is 3B. So 3BI says, list 2 apparatus used to evaporate a salt solution to dryness. Solution, we can use the options, the correct answers are evaporating dish, heater or Bunsen burner, and then tripod stand. So any of these can be used for evaporation of a solution to dryness. We now go to 3BII that says, mention the property of a gas that makes it stable for fountain experiment. Solution, extreme solubility in water. Extreme, that word, that adjective, extreme, must be very important. You have to mention it. Extreme solubility in water. You don't just write solubility, because most gases are soluble in water to an extent. But for you to have fountain experiment, the gas must be very soluble or extremely soluble in water. So we are come to the end of the solution to NECO chemistry practicals 2024, July 2024. So if you're not subscribed to the channel, do well. As the video is playing right now, tap on the subscription bell below the channel. Share our videos to somebody. Share our videos to your friends. Help them out. Share our videos to your friends. Help them out. You can help somebody by sharing the videos. And then to your WhatsApp class group, you can share videos. So thank you very much for listening.